Okay, welcome to the Dublin Academy of Maths. Now, my name is Michael and we're on Series 2, Episode 7, Leaving Cert, Ordinary Maths, and we're doing functions. Today we're drawing graphs. Okay, now the last day we had something like this. So I'm just going to go back over it. We were looking for solutions of this. Now this function is equal to x squared minus 1. Okay. I'll just move this over now. You see the questions here. This question will be related, of course, to this what we're going to do next. So I'm just going to move this across so that you can get a better view. Now, so this function, how do I represent this function? Right, we put the arrow in. How do I represent this function on the graph? In other words, find the solutions. Now I can do it either one by trial and error. I can put in f of 1 and see what happens. 1 squared minus 1. Is it less than or equal to 0? 1 minus 1? Yes. So 1 is the solution. X is equal to 1. Now if I put in 2, f of 2, I'm trying to find more solutions. 2 squared minus 1 is less than or equal to 3. It's not going to work. Okay? And it's going to, as you increase it, it's not going to be equal to 0. Now, so I go down to the minuses, and if I try minus f of minus 1, okay, so minus 1 to be squared minus 1, what's the answer? Minus 1 to be squared is 1, 1 minus 1 is 0, so x is equal to minus 1, right? Now that's a very small equation here, but it represents also cubic equations. Right, large cubic equations with the power of 3 minus 2x squared all the way down. Okay, so if you want to find a solution, you must put in find your roots first. Now there was another way I could have done it, and that was factors. Okay, I can factorize this now. This is the difference of two squares. Do you remember? This is the same as x minus 1 to be squared. Alright, which is equal to x minus 1 by x plus 1. Good. Now remember, you have to know these. Right? So that's the factors. So therefore the factors is x is equal to 1, bring across to 0 or minus 1. Right, very simple enough for those small equations, but there's also another method, okay, and that is to bring it over. So x squared is equal to 0, plus 1, okay, x is equal to the square root of 1. Okay, and the answer is equal to plus or minus 1. The square root of 1 is 1. So if you get any equation, the square root of 49, for example, what's the square root of 49? It's plus or minus 7, because minus 7 to be squared is 49. So there is an irrational root on this. Okay, it's an integer root. Well, they're both integer roots, but this is a negative, so it doesn't really work when you're dealing with area or when you're dealing with any sorts of measurements. Okay, regarding space. Now, so if I want to I want to represent this solution. So I find out and I know that it's plus or minus 1. So I just draw my graph. So x is equal to plus or minus 1. So that's minus 1 plus 1. Okay? And because it's positive, it's going to go like this. Now, it has to go on a smooth curve. Now that's the curve, but it continues on out, okay? Now that's the whole idea of these curves, is that they continue on out. And in the future, or in a certain time, it will hit another point or another line. And you have to be wary of this. You can solve lines by making one function equal to the other and finding the points of intersection. Now more detail will be done on that later. But will be done probably in calculus. Well, no, later in the cubic as well. Now another one is f of x is equal to x squared, again minus 1. Now this f of x is not the inverse, that's the derivative. Now if you follow the rule of the derivative, because I'm going to make this easy now for you, because I don't want to go into calculus, but it is calculus. Okay, so you multiply the power n times the power, n times the x value, and reduce the power by 1. So it's twice x and reduce the power by 1. 2 minus 1 is 1. The derivative of a constant is always 0. Okay, so that's gone. Minus 0 doesn't mean anything, the same as plus 0 doesn't mean anything. Okay, so remember that rule, because we will be doing this again. I'll do another one. 3x cubed minus 2x. Okay, so what do I need? That's f of x. I want to find the derivative of x. I multiply it by the powers, 9x. Reduce the power by 1, as this has happened over here. 3 minus 1 is 2. 1 by minus 2, or 1 by 2, times x to the power of 1 minus 1. 1 minus 1 is 0. So you're left with 9x squared minus 2. Because anything to the power of 0 is equal to 1. 2 times 1. Okay, so you're multiplying 1 by 2 and reducing the power by 1. Okay, reducing the power by 1, which is equal to 0. Okay, so that's the calculus thing over. Now, I'm going to just do a quick question here. Okay, now other graphs, I'll just write out another. Now, a graph with a cubic equation, okay, is something that goes on like this. Okay, now it's repeated. Now it has a repeating pattern. Usually. Not all. Okay? Not all, but just remember anyway. So it has 3 solutions. Okay? 3 solutions. There's the solutions, right, of this value on the x-axis. On this x-axis, f of x is equal to 0. And this is this concept that we have to get into our heads. Right? So all along this line, you're reading that y is equal to 0, of course, but it's also the solutions of this cubic equation. Okay, so the graph really is done with respect to x. Okay, so everything is in respect to x. Now, I just want to show you another one thing here up here. This is the maximum turning point. Maximum turning point, and this is the minimum turning point. Right? We'll get to that in a while. Now, it says where is f of x greater than 0? In other words, where is f of x positive and increasing? Okay, we'll put it in this way, positive and increasing. F of x is y. Well, looking at y, where is y going up? Well, we know that this is all positive here for y and this is negative for x, or for y. And this is negative for x and this is positive for y, for x. So, where is it increasing? Well, it's going up there, as you can read, and then it decreases here to the maximum turning point. And it increases here again at the minimum point, and it goes up again, and it's increasing. So you would find the points, right? So it's usually the middle point of this, and it's usually the middle point of that. Okay? So if this is, I don't know what those values are, but you would find the values from the graph, and you would say, that is the point. Well, let's say that's 2, and we'll say that's 4, and we'll say that's minus 4, because that's the way they go in this case, and this is 2. So you would say that the y goes between, y increases at this value here, which is out there, which is 2, okay, yeah, 2. So y increases when x is equal to 2, and it's 2, and that's the point 2, 0, 2, the point reading from here, 1, 4, and where f of x is increasing, greater than 0, this is these points, and also here. So you would find these points. I'm going to leave this to you, so that's 2, that's 1, and find the points. Okay? Anything else? B is, let me just read out a few things. Maximum turning point we've done. F of x is increasing. Yeah, we've done that. Now, oh yeah, I want to show you something about slopes. Now, if I wanted to find the slope of this line here, now this is also mixed in with coordinate geometry of the line. Now, if I wanted to find the slope of that line, and I bring that line down here, well, I'm looking at my x and y axis here, right? And I know it goes to 4, and I know this goes out to 2. And so what I'll do is I'll pick the 2 points. What I'm trying to say to you is the slope of this line is the distance travelled and the height you went up. Okay? Or it's the height you went up and the distance travelled. Sorry, the wrong way around. Y over x. always y over x, right? Now, that's the same as how y over x is the slope. Okay, I'm going to leave it at that, and then we get back to it again. But remember that you can calculate the slope by putting in the formula, getting your points, y1 minus y2 over x2 minus x1. Okay, I will have to relook at that. y2 minus y1 over x2 minus x1 is the slope of a line. Okay, but you know now that with coordinate with cubic and coordinate geometry here, we can find a lot of things. We can find a point out here, we can make a connection, we can find its slope by its opposite slope, as you can see here, it's perpendicular. There's lots of things we can try and find out, you know, all relative to, you know, speed and velocity, which is coming up next in calculus. Now, slopes. This is a negative slope because it's got a big angle, and I'm reading from left to right. If I was standing there, I'd be walking down. If I was standing here, I'd be walking up. So this is a positive slope and this is a negative slope. So remember that. But when your formulas are due out, your formulas, you will find that they will adjust and it will show you whether it's a positive or a negative slope. Right. Now, today we were going to really do drawing graphs. Okay, so it says draw the graph of the function f of x, which is y, is equal to x cubed minus 3x squared minus x plus 3 in the domain x, because domain x, in other words, where does x lie? What are my values of x? Less than or equal to 4. So you got minus 2, less than or equal to 4. So in other words, they're saying within these values of x, you know, you will find your solutions. Okay? So what we do is we can either put them in a table form, which maybe we should do on the first start. So if I'm putting in my values, I'm going to put them into a table form. Right? I'm going to do a couple of it and you're going to finish it for me. So minus 2, so I can start minus 2, minus 1, 0, 1, 2, 3, 4. And I put down my f of x, my formula, okay? And what I'm doing is I'm just putting them in. You will see them now. X cubed minus 3x squared minus x and 3. And then you get out of a y value when you add them up. Okay, so you have to be very careful when you're doing all these adding, right? And you just get them, you put them into a straight line as such, and you make your table out of it, so you don't get in any errors. Okay. So, what do I do? So, well, I put minus 2 in for x cubed, minus 2 to be x cubed, to be cubed is, you know, it's a minus 8, because anything to the power of minus, an uneven power gives you a minus. Okay. And we put in minus 3 times minus 2 to be squared. Okay, so we have to do minus by minus is a plus, minus 3 by 4 is minus 12. And now you have to be very wary, you need to do plenty of these questions. Minus x. Minus x is minus 2, which is plus 2. And then we just have 3, and we put the 3 in. Right? So we go along and we do all these values, you know, and we get out these values, 1, and then we have 3 all the way across, because 3 doesn't change. Okay, now, and by adding these values, so minus 8 minus 12 is minus 20, plus 5 plus minus 20 plus 5 is minus 15. So that's the first couple, right? And you go along, I'm going to write them out, 3 and minus 3, 0, 3 got that, 0, minus 3, 0, 3, 0, minus 3, 0, 15. Now you just put in your values, as you know, 0 going in for x cubed is 0, minus 0, minus 0, and then you got 3. Okay, so you're adding the red numbers and you're coming out with these, with the blue numbers here as such. Okay, and So you get your couples. So what are the couples? So you get out these range numbers. So you would plot your graph. So f of x, you would plot your graph, and you got -2 minus 15. That's the first couple. And then you got -1 0, because they're always x comes first, and 0 3, and you go along and you get all your couples, right? And then you draw your graph. Now, right, so the graph goes something like, now it's not exact, right? So it goes from, they usually have graph paper, but you should be able to do these out. 1 and 3, it's very far off. -1, 1, and then we have over here is 3. Okay, so the graph goes something like this. It's in, right, anyway, so. Okay, so that's your graph. As you label your axes if you need to. Okay, so, well, do, anyway, x. Now it says, now you've used these couples and you've drawn these graphs. Okay, so -15 would be, that'd be +15, and then down here we had -15. Okay, there were your values, and it says, I'll just read it out. Find when f of x is equal to 0. Find f of x is equal to 0. Well, this is the line x is the same as f of x. Sorry, rewrite that again. Find where your y is equal to 0. Okay, so along that line along x, you will find that y is equal to 0, and the solutions are there. Now, in the original values, you would have got 0 for y, so you can pick out your couples. Do you follow? There was 2 couples here. There was 3 couples actually. There was -1 0, and 1 0, and 4 15. Okay, so right. So no, that's not 3 0. What am I saying? 3 0. Okay, so everything, y is 0, as you can see here. Sorry about that. Y is 0. So they are my solutions, and I can read them off. Okay, so that must have been -1 there, right? And I can read them off. But they are all here. So you have -1 0, 1 0, and 3 0. The next one, it says, write down the domain of the values of x for which f of x is increasing. Now we did this the last day. Where is the graph f of x increasing? F of x increasing, it says, is, the first one is positive and increasing. So we have to get used to these. And in decreasing, it says here. Okay, so this is one is where it's positive and decreasing now. So where is f of x? Where is f of x positive and decreasing? Decreasing. Where is f of x positive? F is positive, everything above here, so that's y. Okay. And where is it increasing? Well, it's starting to positive and decreasing. So it's going at the very top of this, where the maximum turning point is, it's going down. Okay, and it's going down, and it's going, when you get to 0, it's decreasing. Okay, so it's keep going down. It's positive, but is it positive below here? No, it's not. So it's saying, where is y positive and decreasing? In other words, your graph. Okay, is there any other place where it's here, but this isn't decreasing? Okay, where is it? Is it decreasing here? Yes, it is decreasing here. Okay, so there's another set of points. Right? So you would go, first set is from 0, 15, 15 to 1, 0. Okay, for y. And the next one will be minus, these are couples, -1, 0. Well, it's going from -1, 0, but it's decreasing. So it's going from 0, 15 again to -1, 0. Okay? So that's where it's positive and decreasing. So where y is. And the next one, it says where y is negative and increasing. increasing this time. So where is it negative? Okay, so it's negative here. Right? Where is y negative? Well, looking at here, y is negative here. Right? And increasing. Well, there's the 2 points from that point to that point. Okay, and you just look, observe them. And negative and increasing up there. Okay, now it's going up. So it's a positive slope, and here is positive as well. Right. You would find those points, right? Anyway. So that's everything here I'm looking at. Now I'm going to do periods and ranges the next day, but that's to do with calculus. But anyway, you can see that there's something happening here. It's kind of there's a repeating pattern. Well, that's the period pattern, you know. So there's actually, it repeats from there to there if it continues on. But we'll get to that again. Well, anyway, remember, do the questions. Right, I'm going to bring this across now and we'll see how you get on with this question. Now this question says, graph the function x is an element of R. Y is equal to x cubed plus 2x squared minus 5x minus 6. X lies in the domain of minus 4 and 2. That means that x is greater than or equal to minus 4 and less than 2. Okay, now find the values of x for which f of x, for which y is equal to 0. Y is f of x, remember. Okay, number 2, the domain of x for which y is negative and increasing. So you have to find the values of x this time, not y. Okay, find the domain of x for which y is greater than 0. So this is greater than 0 and this is equal to 0. And find the real roots of the equation when y is equal to 0, which means find the solutions where we got along the graph here. Okay, that's great. Do that question. Thank you.